This next module, Module 8 on dispersion, will introduce standard deviation, one of the most common ways of measuring how spread out or dispersed a data set is. This module is the final module in Unit 2 of Math 118 on statistics and data as well. Okay, so what is standard deviation? Again, it measures how far our data is, but particularly how far it's spread out relative to the mean. It's measuring average distance in some ways from the mean. Now, we talked about the importance of having the right symbol when we introduced mean in statistics. Now, for standard deviation, not only does standard deviation have different symbols depending on if we have a population data set compared to a sample data set, but they also have different equations. So it's really important, it's key that we know and pay attention to whether we're dealing with a population data set or a sample data set, because the value for the standard deviation changes. Okay, so for a population data set, we're calculating a parameter value. So we see a Greek letter here. What we have here is a lowercase sigma, which really looks kind of like an O with a tail on it. Okay, and we see in the denominator of this formula, we see capital N, right, which is short form for the population size. Okay, when we're dealing with a sample population, we're calculating a statistic, we see the symbol S is used for standard deviation, and the denominator is equal to N minus 1. It's the sample size less 1. So because the denominator is a little bit smaller in the formula, the standard deviation value is a little bit higher, and that's because the sample standard deviation is actually approximating the population standard deviation. And if we don't have all the data, then we expect that if we had all the data, it would probably have a little bit more variation. If our sample increases in size, we might see more variation in it. Okay. A large standard deviation tells us that the values are spread out far from the mean. A lower standard deviation tells us that our data values are closer to the mean. The smallest possible standard deviation value we can have is 0. We have a standard deviation of 0 if all the values are exactly the same and there's absolutely no deviation. Okay, as soon as we have a single value that differs from the mean, then the standard deviation is going to be slightly larger than 0. Standard deviation is also always positive, so that's good to know. So let's look at doing a standard deviation calculation. Okay, we're going to do this once by the formula and try and make sense of what the formula is telling us. So we have a small data set here, but it's a population. It's got 4 pieces of data in it. So we know the standard deviation is found by taking the square root of the sum of the data values minus the mean, the distance of the data values from the mean squared, and dividing by the population size. Okay, so in order to use this formula, we need to know what the mean is if we're going to figure out how far our data values are from the mean. So we can do that. We can figure out what the mean of our values are, add up 2 plus 4 plus 7 plus 8, divide by 4. Our mean value is 5.25 grams. Excellent. We're now ready to calculate the other values. So the way, if we're calculating standard deviation by hand, we tend to do this is we organize our information in a chart. We'll take each of our data values and we'll give them a row, and we'll figure out how far each of our values is from the mean. And then once we have that, we'll square it, and then we'll add up the sum of those squared distances. That gives us the numerator in the fraction under the square root sign. That'll tell us the sum of the x minus mu all squared values. Okay, so we're going to start going through this. So our first value is 2. What's 2 minus 5.25? Easy peasy, that's negative 3.25. And negative 3.25 squared is 10.5625. Let's move on to the next value. How far is 4 from 5.25? Is negative 1.25. Negative 1.25 squared is 1.5625. Okay, third value, 7. What's the distance of 7 from the mean? It's 1.75. 1.75 squared is 3.0625. Last data value, 8. How far is 8 from the mean? What's 8 minus 5.25? That comes out to 2.75. And 2.75 squared is 7.5625. Okay? Again, our next step is going to be to take all of those squared values and add them up. When we add up those 4 values, we get 22.75. Okay? So now that we have that sum, we can plug it into our formula. So to get our standard deviation, we're going to take the square root of the sum value divided by our population size value. So I take 22.75, divide by 4, square root, and I get a value that's 2.3 and change. When I'm calculating my standard deviation, I'm going to round to 2 more decimal places than what's in my original data. So I'm going to report my standard deviation as 2.38. And the units for standard deviation are grams. So what that tells me is on average, my data values are 2.38 grams from the mean. Okay. So it's not too crazy as long as we stay organized, and a chart is a great way for staying organized if we're calculating standard deviation from the mean. We can also check to make sure that our value makes sense if we interpret it as sort of that average distance of our data points from the mean. And we're going to see standard deviation come up again as an idea for unit of measure in modules 7, 11, and 12 in this course. We're going to be applying this with a normal distribution, okay, and to talk about whether things are expected or not. And so that's what we see this idea of what's usual, what's expected, when do values start being outliers or unusual. So here's a bit of an example of how we might collect information and then try and interpret a scenario using the mean and standard deviation. So suppose Suba and Jackie are both waiting at an emergency room. Suba waits 45 minutes for treatment and Jackie waits 90 minutes. At this particular emergency room, the mean waiting time is 60 minutes and the standard deviation is 15 minutes. Okay, so if we have this number line here and we're thinking about how these values compare, the average wait time, the mean wait time, is 60 minutes. Right? That's what happens on average. That's sort of the expected wait time. Okay? And then we can think about how long somebody waits in terms of how many standard deviations they wait. So Suba waits 45 minutes. That's 1 standard deviation less than the normal time. Right? Jackie waits 90 minutes. 90 minutes is 2 standard deviations more than the average time. Okay. When we think about connecting this back to histograms, data sets with lower standard deviations have histograms that show less spread. Okay. And as far as whether results are usual or not, or when they start being abnormal, 2 standard deviations is kind of where things get more than 2 standard deviations, starts being a bit outside of the average. More than 3 standard deviations starts being very unusual and unexpected. So again, there's a little bit about how we calculate standard deviation by hand, what standard deviation is used for. The next part of the notes, we're going to be looking at how we can use our calculators to calculate standard deviation without doing a manual calculation. We can put our scientific calculations in a mode called stats mode, enter in our raw data, and it'll actually, even for large data sets, let us calculate standard deviation really easily. So stay tuned to the next video to find out more about that. Before I log off, I just realized I wrote down the opposite of what I meant to write about plus or minus 3 standard deviations. Plus or minus 3 standard deviations is very unusual. If you have any questions, don't hesitate to talk to your instructor, visit their office hours, and remember to try your homework.